Yes, I am live and the screen is not stuck. That is amazing. And we will just continue where we left off yesterday. Boot.dev tracks backend. Yep, yesterday we were on this course and we had completed about this much. We had completed 4 chapters. Now we are on chapter number 5. And for today, let me set a target. For today, we have completed telescopes. Let's do 4 more chapters, at least till loops. And the only difficulty that I face in this is that this is very tedious, and most of the things I know already know, but just going through these is just it seems very repetitive and redundant. But still, I'll go through all of them. And yeah, so for today, the goal is chapter 4, 5, 6, 7, 8. Nope, 4 I already did. Chapters from 5 till chapter number 8. And one more thing, since I do not have the premium subscription for this platform, Boot.dev, I cannot submit any activities. So all I can do is just look at the content. I do have access to all the content, but I cannot test my code here. So I can test my code locally here. Let me go to my Python folder. Yep, here. And I can call the factorial function. Wait, let me make a bit of changes to the factorial function so that it takes user input and then prints it. Prints and input, input, enter a number. Yo, that should work. Python 3 factorial.py, number is 5, and answer is 5 because I didn't call the factorial function on that, which is called fact, and this should do it. 5 and 120. That is cool. Now, unit tests. Unit tests. Up until this point, all the coding lessons you have completed have been testing you based on your coding console output. What's printed? For example, a lesson might expect your code in conjunction with the code we provide to print something like this, right? If your code prints the exact output, you pass. If you don't, you fail. A new type of lesson. A new type of lesson going forward. You will encounter a new type of lesson. Unit tests. A unit test is just an automated program that tests small unit of code, usually just a function or two. The editor will have tabs, the main.py file containing your code, and the main test.py file containing the unit test. These new unit test style lessons will test your code's functionality rather than its output. Our tests will call functions in your code, with different arguments and expect certain return values. If your code returns the correct value, you pass. If you don't, you fail. There are 2 reasons for this change. It is more realistic. In the real world, you will be writing unit tests and running them against your code to make sure it works as expected. You can run and debug your code with print statements and leave those print statements in when you submit. Unlike the output-based lessons, you won't have to remove your print statements to pass. Alright, assignment complete the total XP function that accepts 2 integers as level and XP to add. There are 100 XP per level, 100 XP per level. Okay, total XP should cover the current level to XP, should convert the current level to XP, then add this current XP to the XP to add argument and return the player's total XP. For example, it just returns the sum, and it should return the current level, convert the current level to the XP. Okay, there are 100 XP levels. Okay, XP, 100 XP per level. So convert the current level into XP. So level multiply by 100 plus XP to add. Then add this current XP to the add to argument, and then return the player's total XP. For example, if a player is level 1 and gains 100, we have 200. And if it is 2 and this, then 200 for 50. If level is 170, that is goddamn Chad level. The pass keyword is a way to tell Python to do nothing. You will need to replace it in your code. Okay, that is pretty doable. Take a look at the main.test file. Uh-huh. Okay, it imports import main from wait from main import everything. So this function will be accessible in here. Okay, and then run cases. It is an array of tuple. Submit cases equals run cases plus uh-huh uh-huh with this and this should return this and this should return this returns this returns this returns this returns this. Okay. Def function that takes into inputs and expected output, that is these entries, print this. If input is this, expected output is this, result is calling the total XP function on those two inputs, and the actual is this. If result is equal to expected output, print pass, then return true from the function, otherwise print fall and return false. The main function is passed, fail, start at 0, skipped length equals length, submit cases minus length of test cases, run cases, submit cases equals test cases is, wait, test cases is nothing. Yeah, test cases equals submit cases, and submit cases is this, right? Submit cases. If run in globals, test cases equals run cases. I'm making test cases equal to submit cases. Uh-huh. Test cases equal to submit cases. And if run in global, that is, I remember something from school. This means that if this function is already running or something, then test cases equals run cases, right? And skipped is equal to submit cases, that is total cases minus the length of test cases. For test cases, case in test cases, mhm, correct equals give the value of test case. Yeah, I do have to do some stuff in Python. To listen types, console output, print two files, done. That is done. What type of lesson can you safely submit with your debugging unit test? Right here. Debugging when you are working as a professional. Yep, screen is not stuck. That is cool. When you are when you are working as a professional developer, you will typically write code on your computer and test it by yourself before it is deployed to users. That first part of the process is called debugging. You write some code, run it, and if it doesn't work, you fix the bugs. You repeat this process until you are confident that your code works as expected. Run versus submit. If at do boot.dev, the run button is for debugging, the submit button mimics the idea of publishing your code for production use. You should be debugging your code using the run button. you should be adding print statements to your code to make sure it's doing what you think it's doing at different points in the code. Write a line to calculate a value. Write a line to calculate a value. Print the value you calculated. Run the code. Did it print what you expect? If not, fix it. Repeat. You will never lose XP or penalized on Boot.dev for using the run button. However, there are consequences for submitting broken code, just like there are career consequences for publishing broken code to your users. Yep. The submit button will run additional tests. When you use your run button, a few tests will run against your code. Ah, run cases. And if I have submitted, these cases will run, all of the cases. Okay. That's what keeps it fun, and submit cases will run additional tests that you are not able to debug against. That's what keeps it fun and realistic. It is so hard to know what your users will do with your code. Assignment: complete the take magic damage function. It should return the new health after calculating how much magic type damage the player takes. Here is a description of the arguments. Uh, it takes some inputs and then this returns some output, of course. Learning effectively. This course is about to get a bit harder. There is no way around it. If programming were a walk in the park, everyone would be earning six figures as software engineers, but it is not. And to succeed without getting stuck and frustrated, you need to learn how to learn. Yep, you need to learn how to learn. Process for solving hard coding problems. Read the lesson first, figure out the examples before writing your own code. Read the assignment, understand the goal of the assignment before you start writing code. Yep, start writing code. Add print statements. Don't wait until you have written a lot of code to start testing. Add print statements and use the run button to see if your code is doing what you expect at each step. It is easier to find issues in a small bit of code that than in large blocks of code. Keep running, printing, and fixing until you are confident your code is working. Yep. Submit your code if the assignment, and this is Boot.dev specific. Submit your code, compare your code to the instructors. Additional tidbits. Try to use Boot.dev boots before peeking. It's okay to peek at solution. You can reset your code for an assignment. You can set all the cached code from setting this page. You will be personalized for peeking at the code. You will be penalized for peeking at the solution after years. Nope, that is false. Mhm. Temporarily adding printed statements is a good way to debug. Submit quickly, test and debug small pieces of code. Second one is the answer. When you are stuck, which should you do first? Why on X Twitter about how hard it is? And that seems correct. We get the solution and ask bots a question about your code. Yep, third one. Then now, debugging practices. I want to walk I want to walk you through how I approach writing code, complete with all the debugging steps I take along the way. The goal is to write small amounts of code and then test each bit of code to make sure it's doing what we expect before moving on. Trying to write entire programs at once is a recipe for pain and suffering. The goal is to write a few lines, test them, and then write a few more lines and repeat until you are done. This isn't a technique that is unique to beginners. Even senior engineers write code in this way. Assignment: let's complete the unlock achievement function. It accepts three arguments: before XP, arc XP, arc name. It should return two values. I can just return with one value, comma, the next value. Shit, that is big. The player's XP after the achievement logged is the sum of, well, let me just do at least this one. I have to create a function and this is the test file. I can run the test file, copy the test file and run it on locally. The player's XP after the achievement is unlocked, the sum of them before XP and arc XP. Okay. An alert message that says achievement unlocked, achievement name. Oh, achieve arc means achievement. Okay. Before XP plus Arch XP, that will be the new XP, and Arch name will be printed. Yeah, achievement unlocked. Achievement name, where achievement name is the name of the achievement. Let's start by running the code. In the current state, you should see an error like this. That is very basic. I won't be writing code for that. Return null, so they're just saying this is how you do it, and debug how you do debug. Right, moving on. Moving on. Stack trace. Yep, this thing. A stack trace or traceback is a scary looking error message that Python interpreter prints to the console when it encounters certain problem. Stack traces are most common, at least for you right now. When you are trying to run invalid Python code, you need to get used to figuring out scary error messages as a programmer. We might as well start now. Go ahead and run the code in the current state. You should see something like this. Python error, traceback call, file exec, file string, line 1, line 6, line 1, and line 6 does not fucking exist here. Or maybe its error is in somewhere here. The error is in main.py, line 3. This, and then the error is in exec, line 6 due to some reason, and then line 1 is string. Python error traceback most recent call last. This is a standard header that's just letting us know that a Python traceback is what we are looking at. Python traceback, file exec line 6 in module and file string line 1 in module. This and this. This is the start of the trace. These strange exec and string files don't really exist. The Python interpreter is letting us know about them because they have to do with how your code is executed in virtual browser environment. Okay, this is specific to browser, so if I run this code locally, I won't see any problem, I suppose. Hmm. File on this. Now we are getting to the real meat of the error message. The purpose of traceback is to show us the path that Python interpreter took our code before it encountered the error, which can help us figure out what went wrong. Okay, so here these two lines refer to file exec and string. These two things don't really exist, but they are just they have something to do how Python code runs in the browser, which is interesting. How does browser run Python when it only has a JavaScript engine? Chrome has the V8 engine, Safari has SpiderMonkey, and yeah, Safari has SpiderMonkey. And what is Mozilla's engine called? Firefox engine name Gecko. That is very okay. I thought it would be something cool. Um, browser browser engine names. Navigate Gecko Blink. What the fuck? Wait, I wanna see Chromium code. Is that how I can see the Chromium code base? Yep, that is how I can see the Chromium code base, and that is a bit of code which is written in C++. Majority of it, I would love to fucking explore this thing. This is very complex and fucking million comments. Chromium. What even is Chromium? Chromium is an open source browser project that aims to build a safer, faster, and more stable way for all users to experience the project website is this. Okay, to check out the source code locally, don't use git clone. Instead, follow the instructions of how to get the code. Well, git clone will give me the code base, but I need the compiled thing. This was made 5 years ago. 5 minutes ago. Shit. This file just got updated 5 minutes ago. That is crazy cool. 5 minutes ago. The last change. I can just fucking see the change. That is just amazing. They reverted a commit. Hmm. Like I do understand what they mean. Reverting a commit is reversing codes for a commit apps that must contain apps test UI views dot cc shouldn't be dot c plus cpp launcher dot cc. Okay, that is not a big file, just 500 lines. That is it. That is C++ and a lot of included file. This is just beautiful. Okay, so including this many files is not always bad. I thought the more lines of code I write, the worse it gets. But if something requires more lines of code, if something needs to be complex, I should write more lines of code, even if that takes away some efficiency because it brings in clarity. So, when given the choice between choosing complexity and simplicity in understanding, I should choose simplicity in understanding and write more lines of code. Okay, now I'm getting back here. F. Mrs. F. This is the line of code that caused the error. And what is the error? Indentation error. An indent does not match any outside indentation level. Uh-huh. Indentation error. Oh, this indentation does not match any indentation level. Okay, that makes sense. Now, computing. Computing has a few parts which don't show up here. Python numbers. In Python, numbers without a decimal point are called integers. Numbers without a decimal point are called integers, just like they are in mathematics. Integers are simply whole numbers, positive or negative. For example, 3 and minus 3 are both examples of integers. Arithmetic can be performed as you might expect. This subtraction, multiplication, division. Yeah, this one is actually a bit different as float. Division is done as float. Division on two integers will actually produce a float. A float is, as you may have guessed, the number type that allows for decimal values. Okay, assignment. Complete the missing section of the calculate damage function. Okay, assignment is okay. Integers in Python, numbers without a decimal point are called integers. Yep. Integers are simply whole numbers, positive or negative. For example, 3 minus 3. Yeah, floats as a float, as you may have guessed, the number type that allows for decimal numbers. Yep, like this. Dash and dash are numerical types in Python. Integers and numbers. Integers and floats. Integers and floats are numerical types. Okay. Float division. Python has great out of the box support for mathematical operations. This, among other reasons, is why it has had such success in artificial intelligence, machine learning, and data science applications. For float division is like normal division, except the result is floored afterward, which means the result is rounded down to the nearest integer. The that's the nearest integer. Okay? That operator is used for float division. This will return 2 because the actual answer is 2.333, and that will be rounded down to 2. And for this, the actual answer is minus 2.333. The closest integer is minus 3. Closest integer that is lower. Yeah, -3, -3.
Floor division is just like regular division, but there's a slight twist. The remainder is ignored, or truncated, or dropped, at least with positive numbers. Let's go over a few examples, but first with regular division. 6 divided by 3 is 2. 8 divided by 2 is 4. And 6 divided by 4 is 1.5. Because 4 goes into 6 one whole time, and then half a time more, right? Because it goes into 6 once, then we're left with a remainder of 2, and 2 divided by 4 is 0.5. So in all of these examples, we divided one integer by another integer, and we were actually left with, at least in the case of the last example, a fractional part, which isn't an integer. In Python, it's called a float, or in a language like C, it might be called a double. So what is floor division? Floor division is just like regular division, but after the division operator, we have one more step. We floor the result. And floor really just means to always round down, no matter what the fractional part actually is. So while 6.8 rounded might round up to 7, 6.8 floored will still be floored down to 6. And flooring a negative number, like -5.6, actually results in -6, because -6 is less than -5. And in Python, when we want to do floor division, there's actually a special operator for it. The regular division operator is just a single slash, but the floor operator is actually 2 slashes. So 6 floor divided by 3 is still 2, just like 6 divided by 3 is 2, but 7 floor divided by 3 is also 2, whereas 7 regular divided by 3 would be 2.33333. So to use our original example, 6 floor divided by 4 isn't 1.5, it's just 1. Whereas 9 floor divided by 4 is just 2. And that's because 4 goes into 9 a full 2 times, and then the fraction is dropped.
Yeah. Yep. What would this result? 5. 5. This 5, not that 5. That is float. This is integer. Exponents. Python has a built-in support for exponents. I think most languages require a math library for. I can use this for exponent. What is this? This is 8. Sometimes exponents are also shown in text using the caret symbol. Yep.
Exponents are super easy. Really, do not let the complicated, confusing name get to you. An exponent is just a mathematical operator that multiplies a number by itself a certain number of times. But before we go deeper into that, let's just review some even more basic math to make sure that we're on the same page. As you know, 2 times 2 is 4. We're saying that we have 2 2's. Similarly, 3 times 3 is 9. Again, we have 3 3's. It's really 3 plus 3 plus 3. This relationship between multiplying and adding is very similar between exponents and multiplication. 2 raised to the power of 3 just means 2 multiplied by itself 3 times. So 2 raised to the power of 3 is 2 times 2 times 2, which is 8. 2 raised to the power of 4 is just 2 times 2 times 2 times 2. Which is 16. And 3 raised to the power of 5 is just 3 times 3 times 3.
What is it? 3 raised to the power of 5, 3, 3, 3, 27. 27 into 9, 270 minus 27, 280 minus 7, 243.
Times 3 times 3, which is 243. So the results of exponentiation actually get really big really quickly. 2 to the 6th is twice as big as 2 to the 5th. Okay, now that you get that, let's go over just a couple of special cases. Anything raised to the power of 1 is just itself. So 4 raised to the 1 is 4, and 5 raised to the 1 is 5. This one's pretty obvious. This one's a little weird though. Anything raised to the power of 0 is actually just 1. So 5 raised to the 0, 1. 7 raised to the 0, 1. So how do we do this in code? We obviously can't use superscripts because code is just plain text. We don't have that kind of fancy formatting in our code files. Well, Python is actually one of the few languages that has built-in support for exponentiation in the language itself. And the exponentiation operator is just star star. It's like 2 multiplication symbols. So 2 to the 3rd in Python can be expressed as 2 star star 3. which will evaluate to 8, or 3 star star 3, which evaluates to
Mm-hmm. Yo. Um. 8.
27, 3 to the third.
3 to the third. Yep, that is it. And next, wait, I saw control plus. Changing in place. It is fairly common to want to change the value of a variable based on its current value. So I can do this. Plain one. Okay, yeah, that makes sense. Don't let the fact that the expression this minus one is not a valid mathematical expression be confusing. It doesn't matter. It is valid code. It is valid because the way that the way the expression should be read in English is assigned to player score the current value of player score minus one. In this operation, the right hand side player score minus one is calculated first. Once we have the result, we update player score with this new value. Complete the update player score function. It should add increment to current score and then return the new current score. Okay, plus equals. Yeah, plus equals. That is just like C or C++ or in. Does it exist in JavaScript? Huh. I guess it does not exist in JavaScript. Uh, wait, let me see. A equals 5, a plus equals 5. Yeah, that does exist. Yes, plus plus doesn't exist. Yep, it does exist actually. Does plus plus a also exist? Yep. So it does not exist in Python, I guess. The plus plus operator. Other operators, yeah, I can use that in place like that. Plus equals or minus equal, multiply equal, divide equal. We should do crazy things. Scientific notation. That is okay. Let me use scientific notation. Python 3 to print something 16 to the exponent 10 to the power 3 16000 16000. As we convert earlier, a float is a as we covered earlier, a float is a positive or negative number with fractional part. You can add the letter e or e followed by a positive number to specify that you are using scientific notation like this and this. I actually built a parser that converts some number like this into an actual number. If you are not familiar with scientific notation, it is a way of expressing numbers that are too large or too small to be conveyed and to be conventionally written normally. In a nutshell, the number following the E specifies how many places to move the decimal to the right of a positive number or to the left of a negative number. Yeah. Python also allows you to represent large numbers in the decimal format using underscores as the delimiter instead of commas to make it easier to read. Okay, this means 16,000, this means 16 million. Due to the constraints of our app's server, there is a minimum number of players we can have on a single fantasy, and that is just a question. And yeah, I would like to do that. Complete the max players on server function. It takes no input but simply returns three static numbers. Okay, it just returns these three numbers. Use scientific notation to represent these numbers. For example, this numbers in scientific notation are floats. For example, this is actually equal to dot zero and dot zero at the end. This is perfectly fine for assignment. Yeah, I can just write these numbers into scientific notation. That would be cool. Okay, quite a big way to go. Logical operators. You are probably familiar with the operators and or the logical operators deal with Boolean values true and false. The logical and operator requires Both inputs are true to return true. The logical or operator only requires that at least one input is true to return true. Yep. For example, this that is understandable. Print true and true, which is true. Print true or false, which is true. Nested with parentheses. True or false, this returns true, and with the false is just false. First, we evaluate the expression in the parentheses. This evaluates to true, and then this evaluates to false. Print false. Print this false. Print false. What does this go? Wait, did I do the question? No, that is written. What does this code statement evaluate to? True, false, true. The answer is true. Not. We skipped a very important logical operator. Not the not operator reverses the value. It returns false for true input and vice versa. The operator and or not are logical operators. Now, binary numbers are just okay. The way this is Excalibur. This is Excalibur. They are using Excalibur here. Okay, I thought that I wanted to see the metadata and the data for this thing. Well, I actually can do that. Right. Let me copy image as save it somewhere. Um, a desktop fast. Yep. And then right. So, oh, fucking hell. Okay. Hopefully, gladly. Fortunately, I didn't close OBS, so the stream is still going. Yeah. Let me go cdc where I write my C codes and n read image.c include cdio.h main, and in here I would like to make a file pointer which name is file and that's open. Then target is documents. It is on desktop and the name is if. What is the name of the file that I just downloaded? Out UE something. Wait, I saw something. Yeah, this. What is this? Energy saver is on because I'm on fucking low energy. Let me get my charger. Energy saver, background activity, and some visual effects like smooth scrolling may be limited. Okay, let me get my charger and I'll be right back. Yep, and it is charging. Uh, yeah, the name of the file is O something. O U. Oh, that is the file, and I want to open it in read mode. And what actually is it? And I know I'm diverting from the topic a bit, but I want to know this. Yeah, if seek what n file with offset 0, seek the end of the file, and then f int length equals f tell the location of pointer in this of cursor in this file, and then rewind file. That is cool. Delete that, and here jar buffer. Yeah, I can store the file contents in the jar buffer. Get some space from malloc length +1, right, and call read in the buffer. Chunk size 1 and number of chunks is length, and from where read from 5, right. Okay, malloc import malloc, and after read at the end I will free the buffer and close the file descriptor, and yeah, let me do buffer length equals \null and printf. That is just fucking crazy. Printf and this and given the buffer. That is crazy. 70. What the fuck? Segmentation fault. Why? Where? At what part did I got a segmentation fault? Got buffer. Hey, I didn't. I wasn't even able to read the buffer. Right. Started to read buffer. New line. And shit. Segmentation fault. Why? Ftil fseek 0 and right, and then rewind. Segmentation fault. Printf started to malloc buffer. I wasn't even able to do malloc the buffer. Is it in this part? When I'm doing this, do I have to provide in a local path, a relative path? When reading a file in C, do I have to provide relative path? Nope, I can provide absolute path from the base. If I were to provide absolute path from base, it would look something like this. Yeah, that should do started malloc and png got buffer, and remove the print statements. File. Wait, what png is that it? But in the desktop, I have the whole file. Hmm. 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 document type PNG, 18 KBs. All right. Then letting it size. Let me print the size. Which is like, so what am I expecting the size to be? I am expecting it, since it is the file size is quite big. That is, the file size is 18 KB. So it can be 18,100, 18,419. That is the expected size. 18,419. That is actually the size. And if I am reading this much data from the file, why am I not being able to print it? Because I am printing it as a string, or maybe I saw the null character beforehand. Yep, that stopped the printing of the file. Okay. And then in that case, I should make my own print function, which will go and print the whole length of the file. So doing this for int, not this, int I equals 0, I less than length I plus plus, put char buffer bracket I. That's going to be cool. Yep. That is cool. That is my image file, and it does not make sense. But the fact is, the most important fact is that I was able to read. The most important fact is that I know that everything is just a file, just just zeros and ones, which is just fascinating. I used to think that image and video are like something very concrete that is in the computer, but no, it's just zeros and ones. Maybe I was very stupid, but this feels really cool. Plus one, and at the end, new line. Yep, this is cool. Actually, pretty cool that I can just go in and see the file. Okay, how do I save the file? And if I can save the file, can I change some of these bits? Well, the file is, of course, I would guess, in the PNG format, it is encrypted or stored in a certain format, and I would have to know how pixels are represented in the PNG format if I want to like do something crazy with the file. And just the fact that I can even conceptualize all of this is amazing to me. Now, moving on. Not like moving on, but moving back to this. Yeah, binary. How much time has it been? I suppose about 30 minutes. 49 minutes. That is okay. Yep, binary numbers are just base 2 numbers. They work the same way as normal base 10, but with two symbols instead of 10, like this. In each one, yeah, in each one in a binary number represents an ever greater multiple of 2. In a 4-digit number, that means you have the 8th place, the 4-digit, the 4th place, the 2's place, and the 1's place. Similar to how In decimal, you would have the thousands place, the hundreds place, the tens place, and the ones place. Binary in Python, you can write an integer in Python using binary syntax, using binary syntax using 0p prefix. Right. Note, leading zeros are often added for visual consistency, but do not change the value of a binary number.
Most people have heard that binary is the language of computers, and they assume that means it's like some kind of confusing foreign language. But it's actually so much more simple than that. It's actually the simplest number system outside of unary, which, I mean, unary is actually just counting on your fingers and toes. But before we jump into binary, let's talk a little bit about the number system that you're already familiar with, decimal, or base 10. And it's called base 10 because there's 10 symbols in the number system. These symbols. So this circle represents 0 things, or nothing. Whereas this symbol that looks like a line represents a single thing, one thing. This other symbol represents 2 things. This symbol represents 3 things, and so on. So representing the numbers 0 through 9 is really easy in decimal because we have one symbol per number. But like all number systems, it gets a little more complicated when we want to represent numbers that are larger than the total number of symbols that we have. So how do we represent 10 things? Well, we introduce a new spot. We call it the tens place. So we have the ones place where the symbol in that spot just represents that number itself. The tens place represents 10 times the value of the symbol found in that spot. So the symbols 1 and 0 represent 0 single things and 1 10 thing. Let's use another example, it might be more obvious. The symbols 2, 5, of course, represent the number 25, but it's because there are 5 things in the 1 spot and 2 things in the 10 spot. So we take 2, multiply it by 10, and add that to 5. Now, binary works the exact same way, but it's actually just a little simpler. Instead of 10 symbols, we only have 2 symbols, 0 and 1. And instead of ones, tens, and hundreds places, we have ones, twos, and fours places. So let's just count from 0 to 8 in binary, and I think it'll start to make sense. 0 is just 0. 1 is just 1. Now, up till now, this is exactly the same as decimal, but we've run out of symbols. So now we add a twos place. And to write the number 2 in binary, we put a 1 in the twos place, and then we leave the ones place as 0, just like we would have with the number 10 in decimal. So 1, 0 represents the number 2. Then, to count up one more, we just add 1 to the ones place. So 1, 1 is 3. Now we need another place. So let's add a fours place. 1, 0, 0 is 4. 1, 0, 1 is 5. Now we can reuse the twos place. So 1, 1, 0 is 6. And 1, 1, 1 is 7. Finally, the ninth number, 8, well, we need an eighths place. So 1, 0, 0, 0 is 8. All right, one last example. Let's take a big binary number and break down what it is. So let's take 1101, 0001. First, let's just visually mark what all the...
That is 1 plus 2, 4, 8, 16, 17. 17 plus 64 plus 128. 17 plus 64, 64 plus 128 is 188 plus 4, 192. Yeah, 192, and plus 17 is 199 plus 10, 209.
places are. We've got 1s, 2s, 4s, 8s, 16s, 32s, 64s, and a 128th place. So we have 128, 164, no 32s, 116, no 8s, 4s, or 2s, and a single 1. And then if we add all of that up, we get 209.
Yep, that is what we get. 209. What does the binary number this say? Represent. Wait a minute. And yes, the answer for this is 0 to 4, 4 plus 8, 12. And now moving on to the next part. The binary number this is 9. What, 12, 12 plus 1? Yeah, 30. This is 13. And then moving on to the next. What is the largest decimal number you can store in 5 digits? That is 99999. In 5 digits of binary. 5 digits of binary. 5 is 1, 1, 2 power 6 minus 1, 63. 63. Yep, bitwise operator. Yeah, yeah, I know about this bitwise operator. Bitwise operators are similar to logical operators, but instead of operating on Boolean values, they apply the same logic to all the bits in a value by column. For example, you say the number 5 and 7 represented in binary, you can perform bitwise and operation, and the result would be 5. This is this, and this is this, and result would be 5. A 1 in binary is the same as true, and 0 is false. So really, bitwise operator is just a bunch of logical operations that are completed in tandem by column. As percent and is the bitwise and operator in Python, and and is the name of the bitwise operator operation, while ampersand is the symbol for that operation. For example, this and this equals 5, and this 5 and 2 equals 0, because 2 is this, and that just returns 0. Binary notation way. Ampersand is the bitwise and is the name of the bitwise operation, while ampersand and is the name of the bitwise operation, and is the symbol for it. Okay, bitwise binary notation. When writing a number in binary, the prefix 0b is used to indicate that what follows is a binary number. 0b10 means 2 in binary, but 10 means 10. Now this, right? Putting it together, this, and this equals 5. This is 7, this is 5. Binary 5, binary 7, binary and 5, this equals 5. And then guild permissions. Sometimes applications store user permissions as binary values. If I have 4 different permissions, a user can have them and store that as a 4-digit number. And if a certain bit is present as a 4-digit binary number, and if a certain bit is present, I know the permission is enabled. This can be a lot more efficient than storing the entire strings. Let's pretend we have 4 permissions related to guilds in Fantasy Quest. Guild is just a fantasy video game word for team. Fancy. Okay, guild is just a fancy video game word for team. Hmm. Like the Space Guild in Dune. Can create guild, can review guild. These are the permissions. Okay. This means the leftmost LSB, then this is the second, this is the MSB, this one is the LSB, and these are two in the middle. And this in the middle left, and this in the middle right, rightmost bit. If a user has no permission, their binary permission would be 0. And if a user has only the this, oh yeah, that is all the patterns that are possible. And perform bitwise and to get the user's review permissions. User review permissions. User permissions can review guild, right? If this specific bit returns 1, if this returns same as it is, then I will get that there is permission. Complete each of the get bit user permissions and I have to return true or false. Okay, that is doable. And now the video.
In modern web development, it can feel like bitwise operators are the kind of low-level primitives that only Arch users and Torvalds himself use, but that's only partially true. Bitwise operations are used all the time to build authorization systems, squeeze data into tight places for optimal storage, and ensure your network communications are error-free. Before diving into the bitwise AND operator, let's have a quick refresher on the logical AND operator. It operates on 2 Boolean or true-false inputs, and it only evaluates to true if both of its inputs are true. So for me to be a tall, handsome person, I need to be both tall and handsome, and as long as my mom is judging, I'm all set. Now, the bitwise AND operator is just like the logical AND operator, but it works with binary numbers. The binary digit 1 is the logical true, and 0 is false. So, a bitwise operation is really just a bundle of logical operations. So, for example, let's take the numbers 5 and 7. First, let's write them out in binary notation. Then, we'll just do an AND operation on each bit individually and build a resulting binary number. It's important to understand that a binary AND operation will always reduce the total number of ones in the output, which is why it's called masking or filtering. For example, if I have a large, seemingly random binary number, I can mask it with a number that has trailing zeros. And that just means that I only want to keep the first half of the original number and zero out the rest. I really hope this explanation helped. Please like the video and subscribe to the channel if it did.
So this seems like a pretty old video from when he started making this course. Bitwise OR operator. As you may have guessed, the bitwise OR operator is similar to the bitwise AND operator in that it works on binary rather than Boolean values. However, the bitwise OR operator ORs the bits together. Yeah, this is just like the same thing as before, but with OR damage meter. You have been working with some interns to build a damage meter, and I don't have to do this exercise. I can move on. And converting binary, take a number like this, int binary string 2. Oh, that is cool. Python 3, int convert this string, right? This is string into binary, base 2. That is 16. Is that 16? Yep, that should be 16. That is cool. Moving on to new chapter, the second last chapter. Shit, this much comparison? Ah, fucking hell. It's been 1 hour. Okay, comparison operators. When coding, it's necessary to be able to compare two values. Boolean logic is the name for these kinds of operation comparison operation that always return in true or false. Less than, greater than, less than, equal to, greater than, equal to, not equal to. For example, these and video.
Comparing two values is such a fundamental part
Yes, drums. That is amazing. Yes, drums. That is
of
amazing.
writing code. Every day when you log into a website, you enter a password, and that password needs to be compared against the password that you entered when you signed up for the site however many months before. If the passwords are the same, obviously you'll be granted access, and if the passwords are different, then you'll be given some sort of error message. Comparison operators are the bits of code that allow us to do these comparisons between two values. In this video, we'll be talking about the most common comparison operators in Python, how to use them, and how not to mess up and make some common mistakes that many new developers often make. Let's jump right into some code. So I'm going to create a variable here called result, and we'll just set it equal to lane
Magna.
equals Alan, and then we'll print the value of result. Okay, and I'm going to go ahead and run that code. Okay, let's talk through what this code is actually doing. So we have these two strings, lane, left-hand side.
That
In
is
case they're not, we
very primitive.
saw that false.
It
Print it.
compares the strings.
So let's change it up. We'll do lane equals lane. Go ahead and run that. And now I get true, as you probably expected. Now here's a place where sometimes people get tripped up. If we change this capital L to a lowercase l and run it again, think in your mind, what do you expect will happen?
False.
And we'll see if you're right. False. True does we false. The other. All it does is same to a the and 6 will value have 1 and 6 and lines
Yo,
long. And
that's cool.
at each point in your program, it can be hard to know exactly what's happening, right? You think
That is cool and doable. Long comparison operator evaluation. When a comparison happens, the result of the comparison is just a boolean value. It's either true or false. Take the following two examples. That is true and that is true. In both of these above cases, when creating a boolean variable called is bigger with a value of true, because 5 is bigger than 4 is bigger, is assigned the value of true. Yep. Okay. Comparison practice. Car size, truck size, car size less than truck size. That is true. In this case, complete the assignment. Below function, I will not be completing the assignment. Okay, I do not have access to it. Even if I did, that would just have increased the time that I am giving to this thing, giving to the very basics of Python. And I do not want to give a lot of time to the very basics of Python. Now, it is often useful to only execute code if a certain condition is met. Yep, if, for example, in this code, if this greater than this, then do this, else do this. If boss health is greater than 0, then it will be printed uh, Ganondorf. Ganondorf is alive. Otherwise, it will be printed Ganondorf is unalive. 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 And that is uncool. Without a return in the if block, Gandalf is unalive would always be printed. Okay, I have to return that. The code could print both messages in that case when you only want the code within the if block to run. Use return to exit the function orderly. Okay. If practice, remember you can use equal to operator to check if two values are equal. For example, this is equal and moving on, popping off. If else, if an if statement can be followed by a zero or more else elif elif which stand for else if statements which can be followed by zero or one else statements. Yep, if this then do this, if else if else if else if else if. Yeah, that is just the explanation for this code. It is very primitive, like very basic, and I have been doing C, so that is cool. I know how it the branching and stuff happens in the assembly code, so that is nothing to boast, just the fact that this feels very redundant. Here are some basic rules. With if else block, you can't have an elif or an else without an if. Yeah, makes sense. You can have an else without an elif. Yeah. Remember to check if two values are the same using the dash operator, equal to operator. Else if, yeah, that is same. No. Boolean logic. Yep, Boolean logic refers to logic ending dealing with the true or false values. For example, dogs must have 4 legs and weigh less than 100 kilograms. Both conditions must be true. Cats are cool if they go faster than 200 miles per hour or if they are electric. At least one condition must be true because there is or, and here there was, I guess, and in between. And logical operator review. As we discussed earlier, the logical operators and or can be used to perform Boolean logic and review. The AND operator returns true if both are true. Why are they telling us again? Okay, here we are first comparing, and whatever the result is, we are using logical operators on that. Or review, the same for or. Now moving on, refer to the following Boolean statement. Yep, is tall, is fat, is skinny, is short. Result is tall and is fat. That is true. Or is skinny and is short. That is false. Answer is true. True. Now, should serve drinks. Assignment, and that I'll be able to do if I actually did it. This is an optional. This is optional. I can skip to the next chapter if I want, and I do want to skip to the next chapter. Combat advantage. Round trip. And now I am on loops. On loops, and which only has 10 lessons, which is cool. Okay, if I want to do something like this, I can do something like this instead. Let me print factorials. That is just always a go-to statement. It will take in a number and right. Um, yeah. What is it going to do? It is going to do this. Nothing. We can just do int range equals something. That is cheating. Range is this for I in range print fact I. Is that correct? Okay, that is a keyword. Limit right. Python 3 factorial header number from 7 factorials till 6. Okay, because the last one will not be counted. So let me go there and do limit plus 1. Not lang, but Python 3. 7 again, and yep, factorial of 7 is 5040. Okay, moving on. Loops are a programmer's best friend. Loops allow you to do some same operations multiple times without having to write having to write it explicitly each time. That is cool timing. It is just 1 p.m. and earlier I used to start my streaming at 1 p.m. But now I guess I've been streaming for 1 hour and 15 minutes now. I could do this, right? Even though it would save me a lot of time trying to use a loop, trying to use typing to use a loop, especially if I wanted to do the same thing 1000 times or 1 million times. For a for loop can do this like this, right? I replaces the number 0 to 9. In English, the code says start with I equals 0 in range 0. If I is not less than 10, not less than 10, uh, which is specified in this range 0 to 10, exit the loop. Else print I in the console because of this. Add 1 to I, range defaults to increment by 1, go back to step 0. The result is that the number 0 to 9 are logged to the console in order. The numbers A, B in range Z, A, B are inclusive of A. That is, the B will not go inside the loop. White space matters in Python. The body of a for loop must be indented. Otherwise, you will get a syntax error. Right. Loops practice as you remember. A for loop in Python is written like this for entire in range this. In English, it is like this. And yeah, I have a question then. The same thing. New question. For I in range this, print I for number 0 to I in console. What would you Why would you use a loop when I want to run same block of code multiple times to do the same thing over and over without writing the same code? Yep. Because the computer understands loops better than repetitive code? Nope. Because loops speed up your app? Nope. The first one is the answer. Why does the code on the left print 0 to 9099 and not 1000? Because it is exclusive, it is not inclusive. Range function is exclusive, not inclusive. So it does start at 0 with an increment of 1, but does not reach 1000. When it reaches 1000, the loop is exited. Right. And because print I only happens, so it is because of range. Because print I only happens when I is less than or not equal to, only less than, not equal to 1000. Yep, second one is the answer. White spaces. Yep, it is dash to indent required to indent the body of a loop for traditional loop in Python. Yep, it is required. Range function we have been using can also take an additional argument which specifies the interval over which the specified iterator will increase by. Using in our for loops actually has an optional third argument. The step, yeah, I can start a negative loop by providing in a negative decrement instead of an increment. Remember, you can use in practice operators to increase or decrease a variable by any amount. Increase or decrease a variable by any amount. Increase or decrease a variable by any amount. Yeah, that makes sense. Remember, you can use in-place operators. These are called in-place operators to increase or decrease a variable by any amount. Yep. Ascendant. Complete the sum of odd numbers function. It should calculate the sum of all odd numbers starting at up to and not including the end number. And then complete the sum of odd number functions. Sum to odd number functions. It should calculate the sum of all odd numbers starting at up 1 but not including the given end number and return the result. Sum odd dot by limit equals end input enter a number. Not, I don't have to provide new line here. That is cool. And then the sum starts at 0 and then for I in range 1 comma limit with a step up to do sum plus equals 1 plus equals I. Oh, yeah. And then print formatted string sum Python 3 sum 10. Yep, that is cool. And Let me do some till 1 that should return 0. Okay, let me do here limit plus 1. Some 1, I get 1, and for 3, I should get 4. 4, that is cool. Now moving on. While I can use a while loop. Python has another type of loop, the while loop. It is a loop that continues while a condition remains true. The syntax is simple, and I came too close to the camera. While one, while this, do this. Num equals this, while this, do this, and keep increasing the num. That is cool. And then I have optional things which are by definition optional. Random events. There are some stuff. Experience points you have are. Let me go back into here and what is this? Updated the time that it was updated to the latest. It was updated in March 2025. This month. Shit. I have done today's target. That is still loops, but I have to do a bit more so that in the next stream I can end this. So let me do this, and in the next stream I will do the remaining 5 things: challenges and quiz. Okay, and after this I will be learning Linux. That will be cool. Permissions and stuff. That is going to be cool. So, and just when I'm rushing, I can just stop for a while and let it sink in. Let stuff sink in. Yep, that is a lot of chapters. Fucking 24 chapters. But I got this. Well, of course, I got this. I only have to do one thing at a time. Natural way to organize and store data is in a list. Some languages call them arrays, but in Python we just call them lists. Think of all the apps you use and how many of the items in the app are organized into lists. For example, an X, former Twitter, feed is a list of posts, and online store is a list of products. The state of a chess game is a list of moves. This list is a list of things that are lists. Uh, Lists in Python are declared using square brackets with comma separated comma separating each item. Lists can contain items of any data type. In our example, we have a list of strings. Okay. In our example, we have a list of strings. Right. Move on. And the fact about getting deep into all of these things, I can go deep when I face a roadblock. When I'm trying to build something in Python and I face a roadblock, I can ask ChatGPT and go deep about, like, in this case, when I am making a list of strings, then I suppose what actually is happening is that I am declaring a list of pointers, and those pointers are pointing to the first characters in these strings, and these strings are stored statically if they are available at runtime, or I guess, but there is no compile time. So yeah, they are stored in the heap, and a garbage collector collects them afterwards if I'm not using them and discard them. Sometimes when we are manually creating lists, it can be hard to read if all the items are on the same line of code. We can declare the list using multiple lines if we want to. Yep, yep. This is just for readability. When would you declare a list on multiple lines? When there is only a few items, when there are many items, and it is hard to read them all in one line. Yep, second one. When the array contains strings instead of numbers. Nope, second one. Oh, yeah, I'm on the next one. Which types can be stored? Any, all of them. All of them can be stored in a list. Counting in programming. In the world of programming, counting is a bit strange. We don't start at zero, but in one, but we start in one at zero. Indexing. Bob has index zero, one, two, three. Okay, Bob Lane is the creator of this platform, and Alice, I don't know. Alice and Bob are like compulsory, like conventional names, and Brienne, I suppose, is someone that Lane knows. And Lane put himself not the first because he didn't wanted to feel like a narcissist, so he put his name afterwards. That is in index one, and he put Alice and Bob there. So he had to put someone else at zero index at the first place of this list. So, but he beforehand chose that he would like to put Bob and Alice there. So he had this person's name, Brianna, and I am supposing that is a female name. Seems like a female name. So he can either to put Bob, one of Alice or Bob there, or Brianna. And putting Brianna's name in the start before himself would seem might seem like simping. So he had to put Alice or Bob there, so he just chose Bob because I guess that comes and that has three letters and Alice has five letters. So he put Bob there, then his name, then he didn't wanted to put Brianna just beside him and then Alice and Bob covering Lane and Brianna. So he put Alice after himself in between him and Brianna so that he does not seem like a simp or they are just in ascending order of length. That is my hypothesis. Which index refers to the second item in the list, lane 1. See, he chose to ask about himself. Indexing into lists. Okay. Yep, the screen is not stuck. That is cool. Indexing into lists. Now that we know how to create new lists, we need to know how to access specific items in the list. We access items in a list directly by using their index. Indexes start at 0, which refers to the first item, and increase by 1 with each successive item. The syntax is as follows. JavaScript, Go, Rust, Python, C. Okay, I know how to code in JavaScript. I know how to code in C. I know a bit. I'm learning about Python, and you don't even need to learn Python. You can just, I don't know. It is general knowledge how to code in Python, I suppose. It will just take some time to know the very specifics, but generally I guess anyone can code in Python. Then Go and Rust, I don't know anything about them. I'll have to learn them, but in this course I will be learning Go, and Rust I will be learning on my own. And this language is Go. That is cool. Cool. Then list length, len, and then list name gives me the length. Don't be fooled by the fact that the length is not equal to the number of items. The index of the last item because index start at 0. List updates. I can update a list like that. The zeroth element equals to something else. Appending. Yep. List dot append and then item and it becomes this NVIDIA and AMD. NVIDIA is like of course the godfather in the GPU processing stuff, and AMD is getting pretty good in the processor market. I don't know about AMD graphics design in GPU, but I guess the latest AMD GPUs are much better compared to their last ones. Dot pop gives me the last element and also removes it from the list itself. And then in range and print sports I, yep, to print all the items in a list. counting the items in a list. Remember that we can iterate over all the elements in a list using a loop. For example, the following code will print each item. Uh, that is just iteration. No index syntax. Uh-huh. Hmm. For tree in this, I'll be iterating through them and print this. In my opinion, Python has the most elegant syntax for iterating directly over the elements in a list without worrying about the index numbers. If you don't need the index number, you can use the following syntax. Tree, the variable declared using the in keyword directly accesses the value in the list rather than the index of the value. If we don't need to update the item and only need to access its value, then this is more clean way to write the code. Yeah. When should we use the no index syntax? When we want to write code that is harder to read now, when we don't need to know the index, just the value. Yep, second one. And that's the second one. Which method of writing for loops is considered more clean, assuming you don't need the index for item in items or for item in items. Now, finding an item in a list for fruit in fruits, print fruits. Practice the no index or no range syntax. Okay, that is just exercise and assignment. Find the increase. The difference. Okay. hmm This is the rest and I have stuff. Infinity, the built-in float function. Minus infinity and infinity. Convert them into float. Okay, and the built-in float function can create a numeric float point value of negative infinity instead of initializing a base value like 0 or this. Instead of base value 0 or this, you can use float minus inf to represent negative infinity. Because every value will be greater than negative infinity, we can use it as a starting point to help us achieve our goal of finding the max value. Print float minus inf. That is minus inf. Okay, and we are about done. Modulo operator in Python. Modulo gives the remainder. They have a whole lesson on a single operator. That is cool. That is actually cool for people who are starting to learn to code. Slicing the list. Yep. Start, stop, step. A equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 14, 15. Right, and print a starting from the third index, that is 4, till the 10th index, that is 11, with a step of 2. That is wrong. Okay, instead of comma, it has to be this colon 4, 6, 8, 10. Slicing lists. Python makes it easy to slice and dice lists to work only with the section you care about. One way to do this is to use the simple slicing operator, which is just a colon. That is the slicing operator. Okay. With this operator, you can specify where to start and end a slice and how to step through the original list. List slicing returns a new list from the existing list. The syntax is as follows, like this. For example, this prints this starting from index 1, that is this, till 5, that is 2, 2, 3, 4, 5, with a step of 2. So print this, then this, and uh, the last one is exclusive. So this 70 and 20, like this. Yeah, 70 and 20. The above reads as give me a slice of scores and of scores list from index 1 up to but not including 5. Skip every 2-second value. Omitting sections. You can also omit sections, start, stop, or step. For example, this gets all elements from the start up to but not including index 3. This gets from 3 till the end. Yep, from 3 till the end using only the step section. This gives starting from the start until the end with a step of 2. Negative indices start from the end and, yep, give all the elements starting from the end with the step 1. Step is valid 1 here. List operations concatenate. Yep, I can use the plus. Plus is overloaded here. I can use plus to concatenate strings. I can use plus to concatenate lists. I can use plus to add integers, floats, numbers, numeric data types. Checking whether a value exists in a list is also really easy in Python using the in keyword. Print banana in fruits. If it is, then it prints true. List deletion. Delete this index, then print nums. That third index, value 4, is deleted. Delete 1 to 3, right? And delete everything using the del and then specifying the index, right? Tuples. OBS is using significant energy. That is okay and no problem. Tuples are collections of data that are ordered and unchangeable. You can think of a tuple as a list with a fixed size. Tuples are created with the round brackets. Alright, tuples are created with round brackets and can contain any data type. You can think of tuple as a list with a fixed size. They cannot grow, they cannot shrink and stuff. While it is typically considered bad practice to store items of different types in a list, it is not a problem with tuple because they have a fixed size. It is easy to keep track of which elements, which indexes store which type of data. Tuples are often used to store very small groups, like 2 or 3 items of data. For example, you might use a tuple to store a dog's name and it's just 4 years old, and then the dog died. Note there is a special case for creating a single item tuple. You must include a comma in Python. It is not a regular parentheses like this because tuples hold their data. Multiple tuples can be stored within a list. Similar to storing other data in lists, each tuple within the list is separated by a comma. When accessing a list of tuples, the first index selects you the first tuple you want to access. The second selects a value within that tuple. Yep, that makes sense. And like in this case, tuple unpacking. You can easily assign the values of a tuple to a variable using unpacking, like this, which is equal to like destructuring in JavaScript. Error first element. Let's add another function to our inventory. Write a function that returns the first element from a list. If there is a empty list, return the string error instead. Assignment reverse list. This should return this and this should return this. I can start Arrange from the end till the start with a step -1 and keep appending the values in a list. Yeah, range with a negative step. Filter means you are about to write a bit more code in a single function than you have before. Do not try to write it all at once. Start with the outermost loop and work your way inwards, add extra print statements and okay. Running your code often to make sure each line is doing what is expected. You can debug and I can do that. I can do it. I don't know what it actually is, but I am pretty sure that I can easily do that. I've done much more complicated things than that, and the rest is optional. So I'm just going to skip, and we have completed today's target, and I can end the stream. So, wait. Yep, here. Let's see. I have done lists. Then these I will be doing in the next stream, and we will be done with the Python part, with the learning to code in Python. And this felt very redundant because I already know some things about coding, something of a coder myself. I am something of a coder myself, so I already knew a few things about this. So this felt very redundant. I guess the Linux part is going to be amazing. I don't know why, but terminals add shells, file systems, permissions, programs, input, output packages. Of course, it is going to be amazing. It's Linux. Then I have Git, which I have already taken, but I will take again. Build a bookbot. Set up data analysis and report. It is going to be an interesting journey. And that is the end of this stream.